Welcome to this presentation on implementing UI features for trading. In this video, we'll be covering a range of essential topics that are crucial for developing a user-friendly and efficient trading interface. Let's dive in and explore each aspect in detail. Our first slide provides an overview of the key UI features that are integral to any trading platform. These include real-time data display, intuitive navigation, customizable layout, and robust security measures. Each of these elements plays a vital role in ensuring a seamless user experience. Additionally, we'll look at user feedback integration and the importance of performance optimization. For setting up the project, we do the usual things that we do in every project. We will first create the DApp named Trading DApp, and then we will change the directory to that and install the necessary dependencies, which are Redux, React Redux, Web3, and Exhaust. With our project setup, let's create the trading component. This component will handle the user interface for placing, buying, and selling order, displaying real-time order book data, and updating the user's account balance. Let's see the code. So this is the basic code we will be using for the trading component. First of all, we import the React, and then we make the trading function in which we define handle buy and handle sell, and we can implement the functionality in these. And after that, we write the HTML part in which we first write the heading, which is trading, and then input type text. And you can easily understand this code. We have done this a lot of time. This is the continuation of that code. After that, we return this trading heading we have done, and this is the complete code. And finally, we export the default trading. To enable interaction with the Ethereum blockchain, you'll need to initialize the web3.js library and establish a connection to the network. Initialize the Web3 instance by creating a new instance of the Web3 class and passing either the Web3.given provider, which detects the user active Ethereum wallet, or specific RPC endpoint URL, such that the localhost URL. This connection will serve as the gateway for a application to communicate with the Ethereum blockchain, enabling features like fetching account balances, placing orders, and monitoring the order book. Now let's see the code we will be using for this. So this is the basic code we will be using for initializing web3.js and connect to the Ethereum blockchain. Uh, this is a very basic code. In this, we import the Web3 library, and then we start the local host and export the different Web3. And then to manage the complex state of your decentralized application, it is recommended to use Redux. Redux provides a predictable state container that helps you write applications that behave consistently and are easy to test. First, set up the Redux store and create actions and reducers to handle the state related to your trading features. For example, we will be using this code written here for the same. This store will serve as the single source of truth for your application state, allowing you to easily manage and update the trading related data. Next, you'll need to create a set of Redux actions that allows you to interact with the underlying smart contract and update the application state accordingly. For example, the place by order action is given in this code. This action would take the order details such as the amount to buy and then dispatch a place by order action to the Redux store. The reducer would then handle this action by updating the state with the new order information, which would be reflected in the user interface. Reducers play a crucial role in managing the state changes with your decentralized trading application. They act as the central hub for handling actions dispatched from your React components and updating the Redux store accordingly. We'll see at an example of a simpler reducer that handles actions related to placing buy and sell orders. In this code, the initial state is defined as an object with two properties, buy orders and sell orders, both initialized as empty arrays. Then, the trading reducer function is defined, which take two arguments, the state and the action. Then a switch statement is described, in which the function uses a switch statement to handle different action types. Then, handling place by order action. If the action type is placed by order, the reducer returns a new state option. It spreads the existing state properties using the state, the dot state thing, and it adds the new by order from action payload to existing by orders array using the dot state by orders action dot payload. Then we handle the place sell order action. If the action type is place sell order, the reducer returns a new state object and other things are similar to place by order. And then we write the default case. If the action type does not match any case, the reducer returns the current state unchanged. And then we export the reducer. To provide users with a clear view of the current market conditions, the decentralized application of the trading should feature a order book component. The order book component uses the use selector book from React Redux to retrieve the current buy and sell orders from the Redux tool. The component then renders these orders in two separate lists, one for buy orders and one for sell orders. This intuitive visual representation allows users to quickly access the market sentiment and make informed trading. Now we will look at the code how we will do this. The first line imports the use selector hook from the React Redux. This hook is used to extract data from the Redux tool. Then we define a function named orderbook. Then the next two lines use the use selector hook to select buy orders and sell orders from the trading slice of the React or from the Redux state. Then the return part is the basic HTML code in which the middle line is an unordered list UL where each buy order is mapped to the list item li. The map function is used to iterate over the buy orders array and each order is rendered as a list item. The key prompt is set to the index of order to help React identify which items have changed, are added, or are removed. Then finally we export the default order book function. Now we will see how we can display the trading history using the code, which we are going to see on the next page. So let's see the code. We are going to use the use selector from the React Redux here also. So this code will be used to display the trade history. First we import the use selector like we did in the previous code, and then we use the use selector reducer for getting the data, and then we write the basic HTML code, and then we export the default trade history function. Now we will see how to fetch the account balances. We can do this by using the web3.js library, and the balances component uses the use state hook to manage the local host of the account balance. We can use the fetch balance function, which is defined within the hook, which uses the web3.eth.getBalance method to retrieve the user's account balance. And the balance is then converted from V to Ether using the web3.utils dot from V function and stored in the component state. Using this code, we can fetch and display the account balances. First, we import the use effect and use state from React and Web3. Then we define the function balances, in which we use the fetch balance method to fetch the balance and display it. And then we finally export the default balances function. Then, to enable buy and sell transactions within your decentralized application, you need to handle the interaction within the underlying smart contract. We will be using this code for handling the transaction. We first import the Web3 library and contract from .contracts, and then we export a constant place by order function, which is as shown. We have done this a lot of times, so now this would make sense to all of you. And we use the place by order function first to import the necessary dependencies, including Web3 instance, and it defines a asynchronous action creator that takes the user's Ethereum account address and the desired buy amount as parameters. To enhance the user experience of your decentralized application, it's crucial to provide immediate feedback to the users. Feedback for confirmation of any message also. So we can do that by this one. In here, we use the use state reducer from React, and then we define a function trading, in which we set a set message function, and we have a handle by constant, which is a asynchronous function, and we can set the message here by as by order placed successful, and then the basic HTML, and then we export the default reading. Now let's talk about managing state with Redux, which is key part of our trading DI. Redux is a powerful state management library that helps us maintain a predictable state container for JavaScript application. It works particularly well with React and we will be using it to handle the complex state logic of our trading features. Let's see the code which we will be using for this managing state with Redux. Here first we define a constant named initial state. We set the three buy order, sell order, and trade history arrays to 0 to empty and we set the balance to 0. After that, we declare a constant name trading reducer and then we define as an arrow function that takes two parameters which are state and action. Then we define the switch case parameters which are really simple if you look at it. And then finally we'll export the default trading reducer. For displaying balances, we have already seen this script. Here it is again shown. You can see it again. We have discussed this earlier. One of the important features of our trading decentralized application will be real-time updates. This can be done using this code. This code first imports useEffect from React, useDispatch from React Redux, Web3 from .web3 and contracts. Then we define a function named real-time updates, and then we define a constant dispatch which uses the useDispatch function. After that, useEffect is used to run the side effect. Inside useEffect, a subscription is created to listen for new orders event from the smart contract starting from the latest block. When a new order event is received, it triggers a callback function which dispatches an action of type update order book with the event's return value as the payload. The return statement in useEffect ensure that the subscription is cleaned up unsubscribed when the component unmounts or when dispatch changes. Then we return null, and then finally we export the real-time updates function. We can also add some advanced trading features to our decentralized application like limit orders, stop loss orders, and order matching engine. Limit orders allows user to specify the price at which they are willing to buy or sell a cryptocurrency. Stop loss orders automatically triggers the sale for a cryptocurrency when when its price drops to a predetermined level. A robust order matching machine engine is a crucial component of any advanced decentralized trading platform. We can also do the error handling part, which is really important for the decentralized application. Here we use the place by order function the place by order function here demonstrates how to handle errors during the token purchase access. This code we have seen earlier, so you will be able to understand what is this doing. And the function uses a try catch block to capture any expectation that may occur when calling the buy tokens method on the smart contract. We should also add some security considerations like validate the user inputs, utilize HTTPS, and regularly audit smart contracts. Thirdly, validate all user inputs to prevent common web vulnerabilities like SQL injection and cross-site scripting. Ensure all communications between the DApp and the backend is encrypted using HTTPS, and conduct regular security audits of smart contracts powering your DApp. In conclusion, we have covered the essential steps to implement key user interface features for a decentralized trading application using Web3.js and React. We have explored the implementation of order placement, order book display, trade history, and account balances. By following this guide, you can create a powerful and intuitive trading platform that provides users with all the tools they need to engage in decentralized trading. Remember to test your application thoroughly and ensure it offers a seamless and secure trading experience. Thank you for joining me with this session. Thanks.